Hi everyone. Today we're going to discuss something called binomial expansion. Before I define what a binomial is and what an expansion of a binomial is, I want to investigate a few things. The first thing I would like you to do is expand each binomial below. What I mean by binomial is just something that has two terms. X is one term, 3 is the other. So if I take x plus 3 and raise it to the 0 power, what do I get? You should be saying 1 because anything, no matter what it is, raised to the 0 power equals 1. What does it mean to square a binomial? It means multiply by itself. So x plus 3 times x plus 3. So in order to simplify this, we have to double distribute. So the x gets multiplied by everything in there. The 3 gets multiplied by everything in there. So take a minute, pause the video, and double distribute and meet me at an answer. Okay, you should get x squared plus 6x plus 9. Okay, how about the next one, x plus 3 to the third power? Well, that simply means take x plus 3 and multiply it 3 times. So x plus 3 times x plus 3 times x plus 3. And we already know what x plus 3 squared is, or x plus 3 times x plus 3, which is this. So we can take two of them and just replace it with x squared plus 6x plus 9. And I need to multiply it by another x plus 3. So we can take this x here, multiply it by everything in the other parenthesis, take this 3 and multiply it by everything there. So why don't you go ahead and do that and simplify and combine like terms, pause the video, and meet me at an answer. Okay, you should be getting x to the third plus 9x squared plus 27x plus 27. Alright, let's draw a conclusion from what we just investigated. What conclusion can be drawn from the power of the binomial and the number of terms in the expansion? Well, let's look. This power is 0, and there's one term. This power is 2, there are 3 terms. This is a power of 3, there are 4 terms. So what conclusion can you make? Why don't you write something down and pause the video and then resume it? Okay. This is what I concluded. I concluded that the number of terms in the expansion is always one more than the power of the binomial. And what do I mean by expansion? This is a binomial that I'm raising to some power, and this is its expansion, or after I multiply all the terms out. This is x plus 3, the binomial. I'm raising it to a power, and this is its expansion. So what if I asked you to expand x plus 3 to the 4th, or x plus 3 to the 5th? You're probably going to be like, oh my gosh, too much work. Is there an easier way? And yes, there is. There's something called the binomial theorem. And this is given to you on the reference sheet, so you don't have to memorize it. Now, at first glance, this formula looks a little intense. But if we break it down a little bit, it actually might not be so bad. So let's do it by example. So I'd like to expand x plus 3 to the third. And we already know what the answer is supposed to be. And we just did it right up here. So let's see if we can get that same thing by using this formula here. Okay. The formula says a plus b to the n power, a plus b to the n. So in this example, what's my a, what's my b, and what's my n? So you should be telling me that a is equal to x, it's the first term in the binomial, b is the second term, so my b is 3, and you should be telling me that my n is also 3, where n is the power that I'm being raised to. So let's take it term by term. It says NC0. Now, instead of going horizontally like this, I'm going to put my terms vertically, just because I believe it's a little easier for you to see. So again, we're going to focus on our first term, NC0. What is my n here? My n is 3. So that's our first term, 3C0. And then what comes next in the formula? It says a to the n. So what's my a here? A is the first term, so a is x. And it says raise it to the n power. The n power here is 3. Then comes b. b to the 0. b is 3. So 3 to the 0. So instead of writing, see how the plus sign is going this way? I'm going to write them down just because I think it's easier. So the next term is NC1. So N is still 3, C1. Then comes A. A hasn't changed. A is X. But what power am I going to raise it to this time? It says N minus 1. So if N is 3, 3 minus 1 is 2. What comes next? B. B to the first. B is 3. So 3 to the first. Okay, now I'm going to focus on the third term, NC2. N is still 3. So 3C2. Then comes A to the N minus 2. If N is 3, 3 minus 2 is 1. So X to the first. Then what comes next is my B, and it's telling me to square it. So I'm going to do that. 3 squared for B. And then there's a little break in it. It says dot, 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 dot. So you'd keep following this pattern up until NCN. Just so happens we're at NCN because I have 3 as N. So we're up to the point where we would do 3C3 next. So my last term would be 3C3. And now it says do what power? Well, let's look at the pattern. 3, 2, 1. So what do you think this A is going to be raised to? 0. And then we'll look at this pattern. 0, 1, 2, and then should be raised to the third. So now what we're going to do is simplify these terms and put it all together. So in the calculator, I would like you all to find 3C0, 3C1, 3C2, and 3C3. And I'd like you to put them here. We're going to do the first part of each one. So in the calculator, find 3C0, put it here. 3C1, put it here. 3C2, put it here. And 3C3, put it there. Pause the video until you've done so. Okay, you should be getting 1, 3, 3, 1. All right, now I'm going to focus on this. X to the third power is just x to the third. X squared is just x squared. X to the first is just x. And what's x to the 0? You should be telling me anything to the 0 power is 1. Okay, now how about this one? 3 to the 0. Anything to the 0 power is 1. 3 to the first should be 3. 3 squared should be 9. And 3 to the third is 27. So we can simplify a little bit more. I'm going to put this one over here. So this 1 times x to the third times 1 is just x to the third. 3 times x squared times 3 is 9x squared. 3 times x times 9 is 27x. And 1 times 27 is just 27. So now what we're going to do is we're just going to write all these terms out horizontally. So x to the third plus 9x squared plus 27x plus 27. That's it. And that's exactly the same thing here. Now, I know this formula is something that's not easy to follow, but once you see the pattern, it's very simple. So let's revisit what we just did. We always start with the power C0, power C1, power C2, power C power, where the power is 3. The A term always goes first, then the B term. You start with the N and go down to 0, and then the other one is just 0 to 3. That's it. So let's try another one. Okay, so I'd like to expand 2x to the fourth minus y to the third power. So just like the last example, we're going to start with the power. So 3c0, 3c1, 3c2, 3c3. You always stop when you're at NCN, when you can't go anymore. All right, now, what is my A term? This is my A term, so 2x to the fourth. We're going to put that down all the way. Okay, what is my B term? My B term is negative y. Be careful with that negative. I'm going to put negative 1y. It's the same thing. It's just going to help us a little bit later on. Okay, now if we look back at your formula, the a always has the power of what? A has the power of n, so this would be 3, 2, 1, 0, and then 0, 1, 2, 3. Everything is always the same pattern. Okay, so in the calculator again, put in these 3, or these 4, actually, and we're going to put them all here. Alright, you should be getting 1, 3, 3, 1. Alright, now it's time to simplify this piece. 2x to the 4th to the 3rd power. 2 to the 3rd, you do first, which is 8. And then x to the 4th to the 3rd. Multiply these powers, so this should be x to the 12th. And what is anything to the 0 power? You should be saying 1. Okay, how about the next piece? 2x to the 4th squared. 2 squared is 4. What do I do with these powers? You should be telling me to multiply them, so this should be x to the 8th. And what is negative 1y to the 1st? Just negative 1y. Okay, next. 2x to the 4th to the 1st power is simply 2x to the 4th. And now we're going to take negative 1y and square it. Well, what's negative 1 squared? You should be telling me positive 1. And then what's y squared? You should be just telling me y squared. Alright, the last one. What's anything to the 0 power? You should be telling me 1. And negative 1 to the 3rd power? You should be telling me negative 1. And then y to the 3rd is just y to the 3rd. So let's simplify all these pieces. So the first one, 8x to the 12th times 1. That should just be 8x to the 12th. 3 times 4 times negative 1. That's negative 12x to the 8th, y. 3 times 2 times 1 is 6. X to the 4th, y squared. And then 1 times negative 1 is negative y to the 3rd. You can put the 1 in front if you want. So to finalize it, you should be saying 8x to the 12th minus 12x to the 8th y plus 6x to the 4th y squared minus y to the 3rd. Okay. Let's set up example number 3, and you'll finish it. So find the middle term of 3x minus 4 to the 6th power. So we always start with the power first. So 6c0, 6c1, 6c2, 6c3, 6c4, 6c5, and 6c6. So where would the middle term be? Well, just find it. Find the middle. This one with this one, this one and this one, this one and this one. So this guy right here is my middle term. But we're not done. We didn't finish setting it up. Remember, this is the first term that goes in the first set of parentheses, and something goes in the second set. So what goes in my first set? You should be saying 3x. And what goes in my second, you should be saying negative 4. Okay, powers now. Remember, this power always starts with the power out here. So this is 6, and then we go down. 5, 4, 3. And this would be 0, 1, 2, 3. So all I care about is this term. So finalize this for homework, and then try number 4 for homework. If you have trouble, we'll definitely go over these in class. I know they're a little tricky, so don't get frustrated. Just be patient, and we'll go over it tomorrow. All right, good luck.